Okay, time for a brand new day. We're talking about a lot of important stuff today. Before we do that, Minkrelli is doing an extra credit workshop this Friday at 4:30, and then there will be another one next Friday as well. So exciting stuff. Minkrelli is going to go over installing Linux on Windows, I think, WSL. Are you talking about anything else? Other kinds of... Hope your Cerberry wasn't too bad. Yeah, it was. Yeah, I'm glad I didn't go into school today, but first time I had surgery, I didn't take off any days, and kind of was a dumb idea. So I decided to at least teach from home today. Yep, everything's fine. Everything's fine. So let's get going. First of all, the Fizzbuzz TDD assignment has two things. First is on the server. It's half your points. And then the other thing is you need to screenshot your tests so I can look at them because I can't see, correctness doesn't tell me if you did the test cases correctly. So you're going to have to screenshot those, attach them on Fizzbuzz TDD. I set a hard deadline of midnight tonight, so a number of students got zeros and messaged me. They're like, what? And it's just like, attach it. It's just a zero is a great way of motivating students. Let me tell you, when I put up the wrong deadline for hash tables today and gave everybody a zero on it, I got 5 messages almost immediately. So... so there you go. All right. So the new homework assignment is going to be called hash tables, and we're going to be implementing. It wasn't just you, Sims. A number of people. So the hash table assignment is going to be due not today, but next week, and you're going to be going over WSL and then server admin stuff and maybe a Commander of Conqueror. Sure, sounds good. Okay, so the hash table assignment is a 20-point assignment. So it's a 20-point assignment because when it was 10 points, students wouldn't do them. So because not that it's hard, it's just kind of a lot of work if you don't know how to automate properly. So maybe Minkrelli will go over automation with you all. I know I've kind of done it a little bit, and there's examples in the directory of how you can automate your stuff. Basically, the idea is you're going to implement 3 different hash tables. You're going to implement a hash table 3 ways. Let's put it that way. First, using linear probing. Second, using chaining. And third, using either double hashing, quadratic hashing, or just using the STL. Your choice. We'll be talking about these things today. And I've kind of given you an implementation for, at least for chaining, if not for linear probing. So basically, you're going to do 3 implementations, and you're going to see which one's fastest. There's 4 tests you have to do: inserting, searching, removing, and a mixture of the 3 of them. And to be fair, you can't do insert without, you can't do search without insert. You can't do remove without insert. So these will kind of include insert as well in it. Excuse me. And you have to test them over 10 sizes. So you're going to have 3 approaches, 4 categories of tests, 10 sizes. 3 times 4 times 10 is 120 runs. Okay, and you're going to graph them, and then you're going to compare them. So you're going to see which implementation is faster at what. Maybe the standard library is faster than you. Maybe it's not. I don't know. And so the kicker is you're going to write an analysis report. So this is kind of getting you into like computer science grad school. This is what I did a lot of in grad school. Trying this, trying that, seeing which one's faster, presenting to the class. So you write a report. If we need to do this, this is faster. If we need to do that, that is faster. Maybe they all have the same time, in which case it doesn't matter. Just use a standard template library. You're going to just give some... do they do double quadratic hashing? They can pick. For the third one, they can pick which one. Either double hashing, quadratic hashing, or unordered set. And all of them should be on a relatively low load hash table. So whatever that means for you. For me, it's around 10% full. So a low load for me is with a hash table no more than 10% full. And don't do what one of my former students did, which is for the search, they just search through the whole array to see if they can find it. return true if it's in there, false if it's not. It's like, bro, because he made me look bad in front of UCSD. So they were evaluating his code to see if they would give him credit for this class, and they were like, you didn't write a hash table. It's a vector. It's order n. It should be order 1, you know? And then I get an email from my old professor that I TA'd for saying, what are you teaching these guys? I'm like, man, don't make me look bad. My main goal in failing students is so that students don't make me look bad. So that's the cutoff point. You know, if you're going to make me look bad when you transfer. Okay, I'll do C arrays. Okay, do C arrays, you get a C. Okay, so that's it's not hard. I don't think it's hard. It is just going to be a little time consuming. If you figure out how to automate it, it's not time consuming either. All right. So looking at the Fizzbuzz, looks like almost everybody did it. Just looking at the grades here. Looks like almost everybody. Okay, good. Good. So Fizzbuzz under your belt. Not too bad. Any comments on Fizzbuzz? We'll move on into hash tables. I don't know if the G-test suite worked properly for you. Okay. Let's take a look. Anytime I see that, that tells me you're trying to compile the header file. You don't compile header files. Don't, like there's a reason to do that, but if you're doing this, you're probably not doing what you think you're doing. What this does is it creates what's called a precompiled header to speed up subsequent compilations. That's not actually compiling your code at all. Header files don't get compiled. CC files do. Yeah, don't do that. Like that. It could be a dependency. This is the dependencies. That's the things that it relies upon. But when you compile it, and why do we have two different ones here? Oh, I see. So you split the header file. Yeah, that's fine. Okay. Yeah, that's fine. Okay. So the tests are here. You got, see, you don't, see, your header file has all of your function declarations in it. No, definitions. No, declarations. They all start with DE and end in. So a header file, a traditional header file just says what functions exist, what parameters they take, their name, their return type. Done. Don't ever put using namespace standard into a header file, and you don't need include IOStream because your header file doesn't have anything to do with IOStream in it. So this should be just string because that's the only header file you need here. Yeah, what color scheme are you using? Molokai dark. All right, cool. And uses Fizzbuzz int. Okay. I don't know if that should be exposed. Like if you're, let's just remove your star.gch. So, yeah, you probably shouldn't do it this way because you're passing in the same number, x and x. So the min and the max are the same. So this for loop does nothing here. Right, you can just take that for loop out. All this could just be in like here. need you, and we don't need you either because main.cc includes Fizzbuzz. This we don't need either. Like the whole point of a header file is that you don't have to do this. If you don't have a header file, you can just you can just be like, yeah, there's a function named string Fizzbuzz, you know, then you don't need a header file at all if you want to do it that way. That's why all the function declarations go into a .h file. IOStream's fine, that's fine there. Okay. You got your tests. Good tests, 1, 11, 19, 9, and looks fine to me. You might want to do like one more Fizzbuzz or something. Just because you got at least 2 of all the other ones. Just for symmetry's sake. Yeah, Fizzbuzz. Oh, I see. Why are you doing that? That's strange. Min and max. I see what you're doing. Yeah, no. This main loop should be in. This main loop should be in here, right? Because it's main that knows the numbers, right? You're doing 1 to 100. So. So you're scouting it and you're returning it? You're not returning it. You're not returning anything. That's not good. Oh, I see. Huh. Okay. Alright, so if x is less than 1 or x is over 100, return an error. Yeah, you don't have to initialize a string. Strings will initialize themselves. Any class type will have a constructor. It'll initialize itself. It's only primitives that you have to set. You have to initialize. S is equal to this. You're couting it and returning it. That's probably not good. You probably want to just return the value. And rather than doing all that, oops. Probably just can return the values directly. There, it's a little bit cleaner now. Yeah, so you guys see what I did? Cleaned up the header file. You should never have using namespace standard in a header file. Header file should also not include headers they don't need. Because the reason is every time you include a header file and it includes everything in the kitchen sink, it makes everybody that uses your Fizzbuzz function have to include IOStream or even worse, boost or cimage. And so all I want to do is call a Fizzbuzz function, and you're including 100,000 lines of header files. Slows down the compilation time, defeats the purpose of separate compilation. In that case, I would probably just copy the prototypes of the functions I need directly like this, go to main.cc, and just be like, yeah, I'm just not going to use the header file. I'm just going to do this, and just do it myself. If the header is going to slow me down that much. Doesn't matter, you're already including IOStream. It's not going to have any performance penalty. It's just it's a good habit to get into. And the reason why I'm doing this code review with you right now, Portnoff, is because I'm trying to show you guys good techniques. So, yeah, all of this looks fine. Bad tests, yeah, that looks fine to me. And then you got the same for good and bad. You don't have any edge cases though, so that's a problem. So you need to have good, bad, and edge cases. So let's do that real fast. I typically split out edge cases because that's usually where the bugs creep in, right? On the boundary, off by 1 errors are very pervasive. So expect equals 1 should be 1. And then I typically go up and down 1, like that. And then also 99, 100, 101. Okay. And you'll want to have edge cases for Fizzbuzz too as well. You know, 'cause bad tests are like, you know, passing in bad input, passing in squirrel, you know, whatever. Now some people are asking me like, what if you try passing in squirrel? Well, the Fizzbuzz function only takes an integer. You can't pass squirrel to it. It's a type error. You know, so that's not something you're concerned about. If you're writing a function that takes an int, just worry about the int that's passed in. That's the only thing you need to worry about. Okay. Throw in with the rest, why not? Yeah, and that's fine. But I think it's better to we need to rename this. I think it's better to break them out into a separate test. That's just my own personal philosophy. You don't have to. Okay. Okay. So down here we have the Google Test Suite. Static assert false. Yeah. So if you don't use make, it'll yell at you and not compile. Run this. Okay. So and then that's what I was going to do. So we're just going to see out the function here. Now, what I had before, like this, would have worked with your old code. Actually, and this would have worked before with your old code because your code was c-outing things. I don't think the function should be c-outing anything. The whole point of a mathematical-ish function, which this is, you take an input, you give an output. Any c-outs should be sort of temporary, like debugging things. It should be pulled out. I don't think your code should be both c-outing a string and returning a string at the same time. Just return the string, and then whoever gets that string can c-out it or not, whatever they want to do with it. So I think this is the better way of doing it. And then you're doing this. Yeah, that's fine, I guess. That's not going to compile though because I pulled that out of. Yeah, I'll just refactor this as well. And then we'll see if that works with your code because I haven't messed with Fizzbuzz. All right, let's see how much I broke here. Yeah, all sorts of things are broken. All right. String does not name a type. All right. Fizzbuzz.h. This has to be stood string. Okay. Error I was not declared in Fizzbuzz.cc. CC line 9. And I think you meant to say X here. Or you had a for loop before, that's right. Okay. Error cout is not declared in the scope. It's because we're no longer including IOStream. But if you're going to have a cout in here, then that's the place to do IOStream. IOStream transitively includes strings, you don't need both. C-type. What do you have C-type in here for? I think we need that. Okay. Ooh. All right. So you saw what happened there. So we ran the code and nothing happened. And you're like, wait, what? Wait, what just happened? Nothing happened. All right. You can include namespace standard in your .cc file. Yeah, it's bad practice to do it in a header file because a lot of people are really like triggered by that. And so if you give them a header file and they include it and you include using namespace standard for them, they get really mad. So just don't, it's just bad practice to put into header files. And a CC file that you write yourself, it's fine because nobody includes a CC file. So It's fine. But like header files are for other people, right? A lot of times. And so, did you guys see what happened here? I ran Fizzbuzz, and nothing came out. And the reason for that was because I took out the cout statements and had it return a string instead. And it just sort of silently didn't. But why? Why did I take out the cout statement? See, the cout statement's here, but philosophically speaking, I don't think this function should be couting anything. Its job is to take an integer as input and return a string as output. Couting something is a side effect. It's an unwanted side effect. And it's okay if you're like debugging, in which case this should probably be like error or whatever, just to indicate this is a debugging thing. And even better, you should do something like say, if def debug cout or whatever. And so only if you specifically compile the code in debug mode, it'll do that. And yeah, it doesn't belong there. It's a side effect. It's an unwanted side effect. So what we can do is say no discard on this thing. And now, if somebody ignores the return value of our function, watch what happens. Nothing, because I didn't update the header file here. And let's make sure we're using C++20. And there we go. So now it's an error. Okay. So we have a function that we named no discard, or we put the no discard attribute on it. It's not named no discard, but we put that square bracket no discard thing in front of it. You see that? Sort of fizzy buzzy. You see this? No discard means do not ignore my return value. Okay? I'm giving you a return value. That's the only thing I do. If you ignore my return value, there's no point in calling me. Please do not discard silently my return value. Okay? How do you compile the code with make and debug? Typically, you will have, inside of your make, you will have something like, well, sometimes people just do this if they really want to be, pretty low key about it. But more commonly, you'll have a debug compile and a release compile. The debug compile typically turns off the optimizer, or turns on -OG, O lowercase g, which is the optimizer that's safe for debugging. And then they have a release mode where it turns on full optimization, oftentimes turns off debugging. And so you could do something like this. Very common in industry to do this. What that does is it does, inside of your C++ code, it does a hashtag define debug. That's what this thing here does. And so your Makefile can turn on the debug flag, and then you can come down here and say if def debug cout debug mode mod node x. This is never going to run. And if d3d, and we can do something like that, where like it'll announce we're maybe not debug modes. Say Fizzbuzz called with parameter x, and so if we compile the code this way, well, we still haven't resolved the other issue. So the other issue was that no discard, right? So it's mad that we're not using the return value from it. So if we do this, then it will not be upset about us ignoring the function. And so it stops bugs like that. A lot of times you have a function and you don't know, like, if you call the function, if it's going to do the couting or if it's going to return something to you and you need to cout it. And so no discard is a way of tagging a function and saying, you must use my return value or I'll get mad. Okay, so you like no discard? I do too. Unfortunately, they put it on some functions like system, where it returns an error code, and I actually don't care a lot of times if there's an error when I do system. You know, like I'll do something like this, like system echo it's ya boy, you know, into cow say, into lolcat, something like that. I legitimately don't care if that works or not. The system will get mad at you. A syntax error, unterminated quote string. Okay. What am I missing? Maybe single quote here. Unterminated quoted string. System is in C standard lib. I wonder if that's being included. There you go. So I don't care if that succeeds or fails, but for whatever reason, it's tagged as no discard by default. And I don't know why it didn't warn me on this, but usually it yells at me if I'm not checking the error code. And honestly, I don't care. You know, so you're supposed to say if, you know, whatever, die. I really don't care. If the cow doesn't appear, the cow doesn't appear. It's not the end of the world, you know. Okay. Why does it have square bracket? Square bracket. Great question. So the square bracket means it's an attribute. And so there are a lot of attributes in C++ that can be used to tell the compiler things. Okay. And if you type in something that it doesn't recognize, like that, it might warn you. Yeah, but it's actually just a warning by default if you have an attribute that it doesn't recognize, because you know, future standards might come out. You might have an attribute from a future standard. By default, it'll just ignore it. I think I have it set to error if you have a attribute you don't understand. There's a lot of them though, and they're really quite recent. Most of them, like I don't remember if it was either 17 or 20 that no discard came out. Uh, 17. Okay, so yeah, pretty recent. And there are other attributes you can do, like likely, like that, which tells the compiler this branch is more likely to happen than the other branches. You can optimize your code for it. There's a lot of them. We can have a whole lecture on it. Okay, so we're compiling the code. Oh, you're also not doing separate compilation, which is a bit weird. Like, why have a separate .cc file if you're not going to compile them as separate .o files? So let's fix that too. This should rely on main.o, fizzbuzz.o, and that's it. Give you a refresher on CC flags, that, and CC for the G++. So we're gonna do a little Makefile up in here. Libs, owning the libs. Face for a second. So these are all the compile flags we're using. Define debug, define foo, all error messages, even extra error messages more than all. This is the thing that's turning those error messages into, the warning messages into errors. C++ 20, shut up about unused variables, shut up about unused parameters, because when I'm developing, those are just a waste of my time to deal with. Okay, so what we've done here is we've made 3 Makefile variables. And now we can just use them like this. CC flags, main and then the libs come in at the end like that. And let's do a proper makefile for you. So main.o relies upon main.cc and fizzbuzz.h, and we'll copy and paste here. I don't think we need the libs in that one. We're just going to partially compile main.cc and do the same thing for fizzybuzzy.o, which depends on fizzybuzzy.cc, fizzybuzzy.h, and fizzybuzzy.cc. And so what's going to happen is, rather than having to, because your code is recompiling the entire project every time, right? So what it's going to do now is that it's going to partially compile main.cc, it's going to partially compile fizzbuzz.cc into .o files, then it links them together, and your code runs. All right. And you can see here the debug thing is running properly. Then if we want to come up into the Makefile and turn off debug mode, we can just YYP and just take that out. There's better, you can set targets and things like that. Honestly, it's just, for something like this, you can just switch it manually if you're lazy. In debug mode, we would probably turn on -OG and debugging as well, which you would definitely want up in there. For release mode, we would want -03. Okay, so we'll do make clean. And let's do it first in debug mode. So it's going to do a... your make clean isn't correct either. So the make clean needs to not only remove the a.dot, it also has to remove all the .o files and any core files as well. There's a couple extra spaces at the end there. Okay. Make clean, full rebuild. Full rebuilds are the bane of the existence. Yeah, here we go. Ignoring the return value. Error. It's so annoying. It's so annoying. Okay. So we just capture this. Let me just say if error occurred. Yeah, no. An error occurred. Exit. Okay. Just get it to shut up. Okay. There you go. Fizzbuzz. And you can see it's compiling in debug mode. The debug mode is printing out lots of things to the screen. In practice, you would write those to a file, a log file. Your Makefile game is garbage. Yeah, well, that's why we're doing this in lecture right now. It's not just you. Most students aren't very good at Makefile, so I'm showing you ways. Showing you methods, okay? That's how you can make variables in Makefiles. Very common practice. And then you can, what I'm doing here is just two different sets of flags, toggle between them, commenting them out. Then I do a make clean and make and rebuild with a different set of parameters. You can see now it's compiling with -03 on, whereas before it was compiling with -OG and G with debug symbols. So we're in release mode now. Watch how much faster. It's just amazingly faster. It's extremely helpful right now. Yeah. Oh, good. It should be. Okay. So yeah, Makefiles are primo stuff. And then after that, when you're working on things, like if you touch fizzbuzz.cc and you recompile, it only recompiles Fizzbuzz. It doesn't recompile main. It just links it together. So you want to be on top of your Makefile game as your projects get bigger. Makefiles become more and more essential. And if you're going to be doing a lot of cross-platform stuff, there's something called CMake that generates Makefiles for you, and that's a whole lecture in and of itself. Okay, so that's how I'd refactor Portnoff's code. Half an hour. All right, now let's talk hash files. All right, so good questions. So hash files, we're learning. We're not quite going to learn inheritance today, but you're going to kind of use inheritance before you understand it, because it's already set up for you. You don't have to understand actually what's happening with inheritance. This is sort of like one of my secret backdoor methods of teaching, where you're like using something like templates. Like you've been using templates all along, and it's just been vector angle bracket int, and so you understand the angle bracket passes the type, and just yeah. So as long as you don't have to understand, yeah, you don't have to. You just have to do the assignment. But it'll make learning inheritance easier for you. So what I've done is I've created this thing called an interface for your hash table project, because you're actually going to make 3 different hash tables. You're going to make one that is linear probing, one that's using buckets, and a third of whatever kind you want. And all 3 of these have the same interface. All right? All of them just have insert, remove, search, and this thing called change, which just does a search and remove. It's probably going to be 2 lines of code for you. And that's it. So all of them share the same interface. So what's going to happen is that in your main, you're actually going to make a thing of type hash. Okay? But you're going to instantiate it as one of these 3 options, either linear probing hash, chaining hash, or double hash, or whatever you call the third one. And then the code in main will work the same way. It's kind of cool. Come over here and look in main. Basically, you're going to have 3 options here. So if the user typed in, I want linear mode, they type in 0. If I want chaining mode, they type in 1. And so what's happening here is that we've got a pointer, and I'll explain what this thing is, because you've never seen unique pointers before, probably, unless you're a nerd. This is a pointer to a hash table. And what's happening here, it starts off as null. And we're calling new. This thing here is like new. Make unique is like new, but better. No news is good news. And so what's happening is that we're setting this hash table here to specifically be a linear probing hash if you typed in 1. It'll set it to be a chaining hash if you typed in 2. And then whatever you call your third one, you have to put that in there. That kind of makes sense? Because down below, what's going to happen is you're just going to call the same functions. Insert, search, change, remove. And it doesn't matter. Like, from main's perspective, it doesn't know which implementation you're using. You're going to completely rip out the guts of one implementation and put another one in its place. But as long as the interface stays the same, it doesn't care. None of this code will change based on what you're doing. Okay? Thinking Big Kern, I'm going to rewrite Fizzbuzz too. Cool. So, you don't have to know what inheritance is. You don't have to know what unique pointers are. But that's why it's set up this way. All you have to do for this assignment is inheritance, kind of like templating an entire class. It's a different kind of polymorphism. So templates are what are called type polymorphism, where like you can, or generic coding is often a term for it. Inheritance is something we'll talk about later, but it's a different form of polymorphism. Okay, where something looks the same on the outside but is different under the hood. Okay, there's 3 different main ways of doing that in C++. You can do function overloading, you can do templates, and you can do an inheritance, where it has the same interface. Right, you can make a function named foo. It takes an int. You make a function named foo. It takes a double. Right, same foo, same and then you could do that with a template, like template. Make it for all types possible, like that. Inheritance is same idea, where you present the same interface to the world, and the implementation's different, but it's different. And that's a whole lecture in and of itself. We're not going to get into it now. I just want you using it now, and because it's all set up for you. You don't have to type you don't have to do any of it. It's all set up for you. I just want you to use it so that when we learn it, you have a better idea of what's going on here. Now, unique pointers are probably worth a little mention. So let me back out and just do a little memory pointer lecture, or a unique pointer lecture, which is in the memory Here's the tier list for Sims. I was asking about that. All right. So yeah. So like, what if you want to new something, right? Like, let's say you have a class, Bob. Let's make it a struct. Why not? And let's not call it Bob. It's always Bob. Let's make it submarine. Alright, and so we're just going to describe a submarine. It'll have like a name, string, name, int tonnage, torpedoes. Is there an E in there? Is there an E? Ammo. Problem solved. Okay. Think there's an E? Okay. Well, whatever. It's ammo now. Less typing. So, if we were going to new a submarine, right, we could do something like this, right? We could create a submarine pointer named sub1, say new submarine, and its name is the Wolf Pack. A submarine named the Wolf Pack. It's got a tonnage of, I don't know, 1,000 tons or something, and it's got 10 ammo. And then we can do a couple more. This, and the yeeter. Okay, and then if we wanted to print out these things, we could say sub1 points to name versus sub3 points to name. You guys understand? Like, this is all early semester stuff, right? Just make a class, new it. Any problems with this code? It's Wolfpack versus Yeeter. The timeless battle. Any problems with this code? Worked fine, compiled fine, no complaints. Yeah, I didn't clean up after myself, right? So, if I ran this code, g++-f sanitize equals address.cc, it's going to yell at me, right? I leaked 3 times. From line 23, 24. So, bad. So I have to remember to clean up after myself. Now, this gets complicated if you're doing something like this, like a sub battle, void sub, battle, whatever. And it's going to take 2 submarine pointers, sub1, submarine pointer, sub2. And let's say if sub1, let's do a tonnage battle. If sub1 points to tonnage is bigger or equal to sub2's tonnage, it wins. Out sub1 points to name wins, and then we delete sub2 and vice versa. See where I'm going with this? It starts getting really sticky. Because now, you actually can't tell which of these subs have been deleted. Right? Like, if I don't do any sub battles at all, sure, I could do delete sub1. And we just, oops. We can just delete all 3 of these guys, right? You both add your sanitizer turned on, no problems. Here's why pointers suck, or a reason why pointers suck. If you pass these things to a sub battle and sub battle is capable of deleting them, you now have no idea which of your subs should be deleted or not. And there's no way to tell. Right? Do sub battle, passing sub1 and sub3. Okay. Right? We have no way of telling who is still alive and who's not, right? And so, when we try deleting it a second time, we get a use after free bug. We're doing a double delete. This is bad. This is really, really bad. This is such an insurmountable problem that's why Java exists. Okay? This is why Java exists. They realized this problem is so intrinsic to pointers, which are types that don't carry enough information about them. When you get a pointer, you don't know if it's one variable or if it's an array. And if it's an array, how many elements in the array there are. You don't know. When you're given a pointer, you don't know if it's your responsibility to delete it or if it's somebody else's responsibility to delete it. There's no ownership information. Who owns this memory? What, like, because sometimes you pass a pointer to something, you're like, yeah, blow up the sub that died, Sometimes that's supposed to happen. And it's because of these things that people would just memory leak instead of deleting anything, right? It was such an intrinsic problem. Now, let me show you how this works with unique pointers. So with a unique pointer, rather than doing a submarine pointer, you say, I'm going to make a unique pointer, or putter as Arthur Dwyer puts it. So we're going to do a unique pointer like this, and we are going to say make unique, passing a submarine, passing this in. Let's see if that'll work. Yeah. Okay, so now, check it out. Can't call delete on it at all. Do you know why? Because it deletes itself. Hey, that's cool. Unique pointers delete themselves. When they go out of scope, they free themselves. And you could use new with them. You can use new with a unique pointer, but it's safer to do make unique. And so make unique is a exception safe. There's very little difference between it and new, but look, there's no news at all. Okay, make unique is safe. If it throws an exception, the memory's not leaked, as it would be if you did a new. Is there a catch? Yeah, there's one small catch. But first of all, look at this. You can actually use the arrow operator with them. So they actually work just like pointers, right? Like you can use the arrow operator and call functions on them and stuff like that. Now they're not actually a pointer, so this thing's yelling at me because these are not pointers anymore, right? Now let me show you what the catch is. Unique putter submarine sub1 and unique pointer. Sorry, I can't do it anymore. Sub2 and can't call delete on it. Can't call delete on it. Now it's mad. Okay, it's mad because you can't actually pass a unique pointer to a function like this. Do you know why? Because you're calling it by value, right? So a unique pointer prohibits ever copying it. You cannot ever copy a unique pointer. Okay? That's why it's called a unique pointer. There can only ever be one pointer to the summary, to that location in memory. That's why it's called a unique pointer. If you try copying it by accident, like we did right there, where we're accidentally going to create two pointers, and oh Lord, you remember all the troubles we had with deep copies and things like that? Just doesn't allow it. That's why I'm telling you. Like when I do copy constructors a lot, I don't. I delete my copy constructor a lot. It's not that unusual. Is there anything fundamentally different if you're using make unique versus new? Yes, make unique is preferred. And the reason why it's preferred is your new function can throw. And if you knew the memory and it throws an exception, we're not catching the exception, right? Maybe it'll get caught in a later scope. That memory's still been newed and you have a memory leak. So it's just, now if your constructor doesn't throw, it's not a big deal, but it's just always preferred to use make unique for that reason. It's just good practice. And new also makes people very nervous is the other reason. So just, you notice in my code now, I have no news, I have no deletes. It's like Java, right? Like I'm newing things with make unique, but I'm not deleting anything anywhere. And these things know that they delete themselves here. Okay. So they automatically dereference the memory. I can't delete them in here. I'm not the owner of them. These are const reference. The type information now tells me I, Mr. Subbattle, do not own these pointers. I have no right to kill these subs. I cannot free the memory. And that is why they're vastly more preferable than using news and deletes and raw pointers. Raw pointers do not contain enough type information to make me happy, right? I want to know if something is one object or an array. I want to know if I'm the owner when I'm in Subbattle. Am I responsible for deleting this or not? You know, and if you are going to be responsible for deleting it, okay, then you have to call, what is it, move? I don't do this very often. Yeah. And so now when you call this, that actually moves ownership of sub1 into this function here. And so when this function goes away, it deallocates the memory here. And you know that you're not supposed to, and it's dead, right? If I tried, and it knows that it's dead, like it won't deallocate itself in here. If I try doing sub1 points to name here, this is using a pointer after you've done a move out of, like, if you've ever called move on a unique pointer, you can't use it ever again. Unless you're going to, like, make a new, like, do a new make unique or something. This is obviously bad, because I just did a move. Move transfers ownership to somebody else. This will hopefully be a warning or an error, but oftentimes not. Let's try wall extra. Let's see. Yeah, seg fault core dumped, right? So you got to be careful of that. If you ever pass ownership, you can't use it again. Okay. I wonder if claim would detect that. Claim plus plus warn on everything. Let's see. I don't know. Everything gives you too much stuff. Is it like trying to access a null pointer if you use a unique pointer after move? Yeah. After you've done this, you can't use it again. It's just dead. But it's nice because there's no ambiguity. When you're here, if I'm getting a unique pointer like this, I am the owner of it now. If I get it like this, I am not the owner. I do not delete it. Okay? This thing is going to die here. I know this. Just by looking at the types, I know who's responsible for deleting it. They have passed ownership of the pointer to the function. Okay. Now, there's another kind of pointer called a shared pointer. And a shared pointer is very much like a unique pointer. It cleans up after itself. The difference is you can make a copy of it, which sounds good, right? Like it sounds like a good thing, right? Like you make a copy of it. And see, everything works now, right? So I'm just passing in sub1. It's going to make a copy of it. And it's not even that expensive to make a copy of it because it's just a pointer. And there's like a little bit of reference counting or whatever that goes in. But you can do this for like data structures. Like if you want to have, you know, two things pointing, like two pointers pointing at the same thing for whatever reason, you use a shared pointer. But shared pointers are a little bit slower. Unique pointers basically have no overhead. Like they're basically as fast as a regular pointer. That's what makes them really nice. And also, even though they're stricter, like it seems like you'd want to just use a shared pointer for everything, right? Just because you don't have to, like if you make a copy, you make a copy. You know, not a big deal. Like, you know, once all of the copies go away, then it gets deallocated. But in reality, usually unique pointer is kind of like where you should start with because it stops you from doing dumb stuff. And a lot of the times when you have a pointer, you know, you want to be, you know, if you have something like this, you want to usually be passing it const reference, right? But if you need to, you know, make changes to it or whatever, then you just, yeah, sure, shared pointer is fine, right? If you want to pass it to a function and you want this function to like, you know, take out a, sub 1 points to ammo, minus, minus. No problem. A-okay. You know what I'm saying? So, yeah. It just kind of depends what you want. Usually, though, probably you should just start with a unique pointer and just see if you need to make a copy of it ever. And a lot of times you'll be surprised that you don't. So, does that answer your question, Guerrero? What would sub 1 points to ammo minus minus do? It fires a torpedo, loses a torpedo. Yeah. So. Yeah, they're both good. Let's put it that way. They're both good. I don't want to really say one's better than the other. It just really depends on your needs. Let me just conclude with that. It just kind of depends. Like if you want to make a copy, like if you want two people to both have a pointer to the same submarine, like maybe you've got players in a video game, and the players have like a pointer to like the submarine they're on. Shared pointer makes sense. The submarine won't get deleted until everything pointing at that submarine gets deleted. So once all the players who have ever heard of it get deleted and main doesn't know about it anymore, then it automatically frees the memory. But it's a little bit slower because it keeps track of how many people have pointed at it. And so every time you copy it, the reference count goes up. Every time like these guys go out of scope, the reference count goes down. And so there's a little bit of overhead with the shared pointer. Not a lot, but a little bit. And there's basically no overhead for unique pointer. Unique pointer is just pretty rad. Okay, so let's talk about... we got 2 minutes left. Okay, let's not talk about hash tables. Let's continue the conversation on Friday on hash tables. But for your hash table assignment, you've got some cool unique pointer stuff to look at here. So we've got a unique pointer hash table, and then we're calling make unique. And so it's either going to make the hash table a linear probing hash, or a chaining hash, or whatever you're going to call yours, based on the user input. So it's going to select a hash table. And then all the rest of this main here is done. And everything works. Table points to function, table points to function, because all of them share the same interface held here. This is called a pure abstract or a pure virtual. This is an abstractee. Vim error there. This is an abstract class or a pure virtual class. Basically, you can't make a hash. None of these things have any code. You see the equals 0. All of them have been deleted. You can't actually make a variable of a hash class. You can't do this. Hash int 100. It will get mad at you if you try doing this. It's an abstract class. So whenever you make one, you have to make it as a linear probing hash or whatever. But with pointers, well, we'll learn about that when we study inheritance. But yeah, there's some magic that takes place with inheritance and pointers and things like that, which is why it's set up the way that it is. But basically, all you're going to do is come in here, and for the chaining hash, like I've given you source code for how to do a chaining hash. Thank you, Ada. That's out in public. You can just plug those in here. The only thing I haven't given you, I think, is change. Change. If you say change all the 8s to 10s, you search to see if 8 exists. If it does, you delete it and insert 10.
Does it exist?
That's basically all you need to do different. For the constructors, you need to resize them to fit the size. So whatever your backing store is that you're using to hold the data, like I'm using a vector here. So for this one, it just resizes itself. So if you say, hey, give me a linear probing hash of size 10,000, it makes the vector of size 10,000. And then it has a second vector that keeps track of whether each spot in the array is open, has data in it, or has been deleted. Because deleting things from a hash table is a little bit weird, and we'll talk about that on Friday. But I think in the meantime, you should just be able to do this one. Okay? And then we'll talk more about this stuff on Friday. Okay? What does override do? So override is, it tells it that we're overriding this function here. So virtual means, well, we're going to have a talk on inheritance, but basically this means my kids will be overriding me. And then when you override them, you put the override command there. You don't have to. It'll work without it. It's just good practice. Because if you screw something up and like you put in a const and that one's not const, it actually won't override it.
How many grams are in a kilogram?
Which part would automation help with? The testing. How many grams in a kilogram? 1,000.
Okay.
So I've got a timing script in there that has how to automate your code. We can talk about that on Friday too. Got some sample test cases in here. Insert search. And it's got just 100,000 inserts followed by 100,000 searches. And then we got one for 200K and 300K, and I have a sample one called mixtape, which has a mixture of inserts and searches and removes and things like that. So you can get started on that. Basically, I just get chaining done for now, and then we'll pick it up again on Friday. All right. Where's the source code located for the chain hash? It is in /public. So many.
Are there 1,000 milliliters in a liter?
Yes. Hashimapu. Let's see. Is that it? No. Hashimapu 2. Yeah, this one. So this is what we did last class Sims, where we did insert, search, remove. If you wanted to go faster, you can pull the dot out and use a square bracket. No discard is there, so that if we don't do anything with the return value from search, it'll get mad at us. And so that's the entire implementation right there of a hash table. It's not really a hash map, it's actually an unordered set. Whatever. I just like the word. Hashimapu. Hashimapu 2. So it's this one right here.
Czechoslovakia.
Yeah, sorry about that. But you did get to hear about Sigsy, and the online people didn't, so there's that too. And then there's also one called hash browns smothered and covered, which is another implementation. Basically the same thing. Yeah. Okay. All right, that's all, everyone. Yeah, so Seaside 26 got moved up to 9 a.m. and it's probably going to be hybrid. So we're going to have the option of taking it either in person or online is the plan for next semester. Okay. All right, I'll see you then. Check the schedules. They all changed. All right. Yeah, thanks, y'all.